going to start this week's programme by talking rubbish. Now look at this. This is the junk that one family produce in the course of just 1 week. So you can imagine how much that comes to in a year. It works out as about 6 trees, 150 kilograms of vegetable matter, 50 kilograms of metal, 50 kilograms of glass, and about 40 kilograms of various sorts of plastic. But once your dustbin's been emptied, where does all the rubbish go? Well, at the moment, most of it goes into holes in the ground. Some of the rubbish is biodegradable, so it'll rot away, and it gets broken down by bacteria. And in some tips, the methane gas that the bacteria produce is actually used. It's collected through a network of pipes, and the gas is then cleaned and compressed and used for fuel. A few local authorities burn their rubbish in incinerators. They reduce 100 tonnes of rubbish to 30 tonnes of ash and generate power for electricity as well. But there is another way of using rubbish. If it's sorted out into different types of material, for instance, paper there, metal things, glass, plastics, and so on, a lot of it can be recycled and used again. Now, as most of the Earth's resources won't last forever, that seems like a good idea. Metal is well worth recycling, especially aluminium. We get through 3,000 million drink cans each year, and metal can be used over and over again. Paper and cardboard can be pulped up again and made into new cardboard or paper. The process helps save trees and uses only half the energy and water needed to process new wood pulp. Everybody's seen bottle banks for recycling glass. It's important to keep the different colours separate, or recycled glass would all be brown. The broken glass, or cullet as it's called, is melted down and made into new bottles. There's no shortage of the raw materials for glass, but the good thing about the recycling process is that it leaves fewer holes in the ground and uses less energy than making new glass. Now, metal, paper and glass have been around in our rubbish bins for a long time, but plastic is fairly recent. A lot of the plastic we throw away is just packaging, stuff like this. But if you have a look around your home, or even just the room that you're in now, you'll be amazed at how many things are made of plastic, including your clothes. How about trousers made out of pop bottles? Now, it's not as daft as it sounds. These bottles can be recycled, spun into fibres, and mixed with polyester to make more normal trousers like these. Anyway, somebody who knows all about recycling plastic is John Ashcroft of Polymer Technologies. John, what is plastic?
Plastic is made up of polymers, which are long, complex molecules which come from oil.
We use a lot of plastics these days, and there's a lot of different types. So what are some of the most common ones?
Polystyrene, PVC and PET.
Well, we know what the first two are. What's PET?
PET is very similar to polyester. It stands for polyethylene terephthalate.
Well, I won't repeat that. What's the main reasons for recycling plastic?
Well, firstly, because plastic comes from oil, and that's going to run out shortly, it needs to be recycled. And secondly, it's non-biodegradable, which means that it's not going to decay naturally.
So in other words, the more plastic we use, the bigger the problem. It makes sense to recycle it, and this is how they go about it. The plastic arrives at the factory in batches from different manufacturers. This is part of a batch of PET bottles from a soft drinks firm. It's going to take a lot of processing to separate the different plastics and get rid of the tops, labels and rubbish in the bale. The factory also processes preforms, which are PET bottles before they're blown up to full size. The bottles are too bulky to handle easily, so they're fed into this machine, which chops them into granules. Now, the granules are still contaminated with glue, bits of label and all sorts of other junk. 1-ton boxes of the granules are tipped onto a vibrating screen which sieves out large bits of rubbish. Then the granules are cleaned up in separation tanks. The water and chemicals dissolve the glues and separate different plastics. A lot of the rubbish then floats to the top as scum. This machine dries the cleaned up granules because too much water makes the plastic look cloudy. There's a small laboratory at the factory where they can test the moisture content of the granules. They also check how easily the plastic flows when it's melted. This is how the plastic all ends up. How much PET do you recycle in your factory, John?
Well, currently we're recycling about 80 tonnes a month, but we have the capacity for up to 400 tonnes.
Well, why don't you do more?
Well, one of the problems is, in the form you see it here, this material can be transported very easily, but this is the equivalent of 10 of the bottles that you can see at the front. And these are very bulky and very light, and it just isn't economic to transport fresh air around the country.
Right. Well, that's where you come in. There's a real problem for you to solve. Collect some empty PET bottles and see if you can find a way to make them smaller so they could be collected and transported more easily. And think, could your method be used in high street bottle banks? You see, in some countries, it's illegal to sell these bottles without a returnable deposit system. Now, do you think that would work in this country? And who would be responsible for recycling the bottles? Should it be the drink manufacturers, the shops, the local council, or even us, the consumers? Right then, John, what kind of things are made from your recycled plastic?
Well, there's a wide range of things can be made. As you can see here, we've got flower pots, milk crates, air freshener holders. If we look at PET, we can make industrial strapping, such as this, or even fibre, which can be used for filling duvets, anoraks, or even woven into cloth.
Right. So you don't make it into more PET bottles, then?
No, unfortunately, the purity we can get the recycled material to prevents us from using it in the food and drink industries.
Right, then. What do you do with all the mixed colours of plastic and so forth that, say, come from household rubbish?
Well, when you get mixed colours, such as we have here, which is called jazz, it can only be used for brown, light grey or black products. Even the low grade, though, can be used for road fill materials.
And how does the price of your recycled plastic compare with the new stuff?
It's about half the price of new.
That sounds fair to me. Now, what are the main problems? You start off with a bottle like this, and no lemonade, obviously. But before you recycle this bottle, what do you have to do?
Well, there are a number of problems. First of all, there's the base cap, which is a different type of material, which is stuck with a special adhesive to the bottle. You've got the label, which is stuck with a similar adhesive, and you've got the top, the cap, that's used to fasten it. Right.
So, think about this yourself. See if you can find a way to unstick the base cap easily. Now, you can try cold and hot water. You can even try putting the bottle inside the freezer. And try different solvents for getting the paper label off. Here's a few ideas. This one's H2O, of course it's water. White spirit, we've got methylated spirit. This one is propanone, but you probably know it as nail polish remover. By the way, do be careful if you use flammable liquids. And you can have a go at other containers as well. You don't have to test the whole label. Cut the bottle up and just try one or two small pieces. Now look, John, a lot of the plastic we use at the moment looks the same. For instance, these ones. How would you go about separating those?
Well, you can separate those using a technique that we use in the factory. It's called flotation, which is simply separating the material by whether or not it can float or it sinks in water.
Well, we've got one or two bits cut up here. I'll just drop these in, see what they do. We can see the white ones seem to be sinking, the red ones are floating. But it's important to give it a few minutes to see if it works, and also give it a stir. There, I've got the white ones to the bottom now. It can take up to 10 minutes. There you are, see how you get on.
If you stand on a chair and reach up to the ceiling, you'll notice how much warmer it seems up there. That's because hot air rises. And in fact, the ceiling gets pretty hot before it's warm enough down below for us to feel comfortable. The problem's even worse in a large building like a hall or a warehouse, but there is a simple answer. It's an air recirculator. All it is a fan at the top end, recycling all that warm air from up there by the ceiling, which is doing no good to anyone, and pushing it through this long black plastic tube down to floor level. And that's where people are working, and so that's where it'll be useful. And if I put my hand down there, I can really feel a good strong blast of warm air coming through. So, think of the saving. All that warm air is now down here helping with the heating instead of disappearing straight through the roof. Adrian Smith is the sales manager here. Adrian, what difference has installing these air recirculators made to your fuel bill?
Well, before the units were installed, we were running 2 boilers all day long. Now we're only using 1.
So that means it's virtually half your fuel bill.
That's right.
And yet it's really quite warm, isn't it?
Yes, it's a much more comfortable place to work in.
Air air recirculators come in various shapes and sizes. This one's very cheap to run. It's 22 watts, a quarter of an ordinary light bulb, and it comes from the Centre for Alternative Technology in Wales. It's the kind of thing, in fact, you could use for doing your own experiments, or you could, if you wanted to, make your own. What you need is an electric fan, preferably a 12 or a 24 volt one, and you can get plastic tubing like this from commercial suppliers. Or you could even cut the bottoms off carrier bags, bin liners, food bags, whatever, tape them all together, but they must be about the same circumference as the fan. Now, if the plastic's a bit thin, you may need to make some sort of rigid cardboard ring or coat hanger wire to make it more stable, and perhaps a few more up the length as well. Now, you could use an ordinary fan heater, but it must be the sort that allows you to leave the heating off and just switch on the fan. It's not quite so cheap to run, but it'll do if it's only an experiment. But make sure you don't cover the intake vents, though. When you've hung the recirculator safely from the ceiling, get well clear of the fan before switching it on to check it. Now, you can just take the temperature at floor and ceiling level with a couple of thermometers, but if you've got a data logger like this and temperature probes like these, you can let them do the measuring for you. This one can take 4 measurements at once. Try different positions in the room, as well as the ceiling, middle and floor level. Try near a door or window, or perhaps next to a radiator. And it's a good idea to put one probe outside the window, see if the weather affects your results. Well, we've got 3 of these probes plugged in here in the studio, and we're measuring the temperature. The channel 1 probe is right at the top here. Have a look and see what it's measuring. That's about 20.6 degrees. The channel 2 probe is here at desk level. That's measuring not much different, 20.7 degrees, but then of course there are all these studio lights around. The channel 3 probe is down there on the ground, and that's measuring about 18.8 degrees. Now, as I said, the studio is hardly a normal place to do this sort of experiment, but we have been running a 2-day experiment in a living room with temperature probes at the ceiling, this is channel 1, and at floor level, which is channel 3. Now, the first day's temperatures were taken without the air recirculator on, and the second day was taken with the air recirculator switched on. Let's have a look at that in a bit more detail. Now, the experiment started at 7 o'clock, and at 8 o'clock, on was switched the central heating, and the temperature of the air here up on the ceiling rose very quickly, and those little blips there are just where the thermostat was cutting the boiler in and out. And by the end of the day, the temperature had really got quite high, and the central heating got switched off at the end of the day, and the temperature goes right down during the night. Next morning starts up again. Now, the story down here on the floor is very different indeed. 7 o'clock the experiment starts, and at 8 o'clock the central heating gets switched on, and the temperature starts to rise, but really very much slower than it had been doing up here. And it never really gets as high all day. In fact, the temperature on the floor is up to 9 degrees lower than the temperature on the ceiling. Now, there's the end of the day. The central heating got switched off, and during the night the temperature went right down again until the next morning, where you can see the central heating being switched on again at 8 o'clock, and the temperature starts to rise in the same way as it did the previous day. But look there, at 10 o'clock we switched on the air recirculator. I think you can see that the temperature really jumps there. And then for the rest of the day, the temperature is overall a lot higher than it had been on the previous day. In fact, the temperature on the second day on the floor was only about 3 degrees lower than the temperature on the ceiling. So the air recirculator was really doing its work. Now, that's the end of the day there. The central heating was switched off. And we kept the air recirculator on. And you can see that the temperature dropped much more slowly on that day, on that night, than it did on this night. Now, of course, perhaps not everybody would really want to have an air recirculator in their living room. In fact, it's a pretty ugly thing. Maybe you can think of a way of making it look a bit better. But it certainly does make the room feel warmer, and it does solve the problem of frozen feet.
As scrap metal goes, this lot's all pretty upmarket. You see, jewellers have a lot of scrap left over like this. Then there's a lot of silver in photographic plates, such as these old X-rays. There's also a certain amount of silver in old coins. And the electronics industry uses silver, gold, and even platinum in some of its components. So as you can see, this sort of waste is well worth recycling. The metal is put in a crucible and melted down in a furnace at a temperature of over 1,000 degrees Celsius. Small test samples are taken for analysis to find out how much gold and silver there is. The rest of the metal is poured into bar-shaped moulds. There are much larger furnaces as well that can smelt several tons of material at a time. This one's producing 95% pure silver. There's a large laboratory and samples are tested at all the different stages of the processing. Some of the scrap metal is a bit less glamorous. These barrels contain industrial waste called tank house slime, but it's rich in waste copper, and that can be purified by electrolysis. The coppery sludge goes into this tank where it's mixed with sulfuric acid and forms a copper sulfate solution. That's run off into long tanks, which have pairs of electrodes in them. Now, when an electric current is passed through the plates and the copper sulfate solution, the copper particles are attracted to the negative electrodes. Layers of purified copper build up, and you end up with what's known as cathode copper. You can have a go at copper plating yourself if you like. All you need is a beaker of copper sulfate solution and a low voltage power supply, or even a 6-volt battery will do. Now for your electrodes you can use a pair of carbon rods, or here I've just got a couple of nails, but make sure they're really, really clean. Now I'm just going to put them in the solution, suspend it on a bit of cardboard, and the current passes between the nails right through the solution, and you can see that because it makes this little light bulb go on that I've got in the circuit. There we are. When you've run the experiment for a while, one of your electrodes should become plated with copper. Now maybe you can think of a way of working out exactly how much electrolyzed copper you've got. And it's worth testing the acidity of the solution during the experiment a few times as well. These are silver crystals which have been refined using electrolysis. And you can do the same thing with gold. And this is your end result. It's 99.9% pure. This is a silver bar. And this weighs 32 kilograms, which is more than half what I weigh. I've got to admit, I wouldn't mind recycling 1 or 2 of these myself.